So, as a warm-up today, I'd like you to find the IROC at t equals 5 for this one.
In the folder.
Exactly. Yeah, tests can go back in the folder and stuff like that. All right, so we're gonna find the IROC here, and it's going to be the limit as t approaches 5 of s of t minus s of 5 all over t minus 5. Well, that's going to become the limit as t approaches 5 of 2t squared minus 3 minus s of 5. So 5 squared is 25 times 2 is 50 minus 3 is 47. So we have factors there. The t minus 5s cancel each other out. Leaves me with and now we can send t to 5. We can straight up substitute t equals 5 in there. So then this would become 2 times 5 plus 5. 5 plus 5 is 10. Times 2 is 20. So we get an IROC here at 5 seconds of 20 meters per second. There wasn't really a unit on this one, but we'll throw it meters per second in there. Agree? Okay. Same problem now. Same problem, but I'm going to do the IROC in a little different manner. Instead of yesterday's, where we had the interval went from, in this case, 5 to t, okay, and then we sent t to 5. Now I'm going to go with an interval of 5 to 5 plus h. Okay? And I'm going to send h to 0. That will give me my instantaneous velocity in this case. Now, when I do that, the same process happens, the same mathematics happens. Okay? So it's still going to be the limit as now h goes to 0 of s of 5 plus h minus s of 5 all over. Now the difference here is is that my denominator would be normally 5 plus h minus 5, right? Well, that's always going to simplify just to h. So it makes your denominator be a lot cleaner. Doesn't have to worry about factoring anymore because now it's just a straight up h. Okay? So my limit here now, as h is going to 0, s of 5 plus h, so that would be 2 times 5 plus h quantity squared, minus 3, and then minus s of 5, we figured that out before, that was 47, all over h. Okay, well, on a little sidebar action, 2 times the quantity 5 plus h squared is like 2 times 5 plus h times 5 plus h, which is like 2 times 25 plus 10h plus h squared, which is 50 plus 20h plus 2h squared minus 50, because minus 3 minus 47 is minus 50, all over h. Now, here's where this one is nice. All of your non-h terms should drop out. 50 is my only non-h term. 50 minus 50 is 0. Now I've got nothing but h terms there. And since I'm dividing by h, that simplifies to 20 plus 2h. And now I can send h to 0, which means any term with an h in it is going to go away, and that's going to give me my IROC here at 5 seconds is 20. Again, we threw the meters per second on there. Okay. Question? Oops, I don't want to extend the page. I want to go to the next page. There we go. All right, so here's our new function. Okay? Our new function is f of t is equal to 30t minus 5t squared, representing the distance in meters an object is from its starting point in t seconds. Okay? Part A, how far is the object from the starting point in 2 seconds? How far away is the object from the starting point 2 seconds after we release it? What do I do? No. So what do I do? No. What am I looking for? I'm looking for how far the object is, right? Plug in 2, 4 in my function. So I need to find here f of 2. So I get 2 seconds after we release it that object is 40 meters away. Agree? want you to do now is I want you to find the average rate of change, the AROC, if you will. Find me the AROC over the interval of 1 second to 4 seconds. So that's going to be f of 4 minus f of 1 all over 4 minus 1. F of 4 is going to be 30 times 4 minus 5 times 4 squared. Then minus f of 1 is going to be 30 times 1 minus 5 times 1 squared. And that's all going to be over 3. 30 times 4 is 120 minus 4 squared is 16 times 5 is 80. 30 times 1 is minus 30, and then that's going to be plus 5. Because that's minus 5 plus 5 all over 3. So that gives me 40, 10, 15. 15 divided by 3 gets me an AROC of 5. Yes? Okay. Find me now the IROC at 2 seconds. I'll rewrite F here. And when you do this IROC, do it the H method. Don't do it the T method. Do it the new method I just showed you in the last slide. Do it that way. So F of 2 plus H is going to be 30 times 2 plus H minus 5 times 2 plus H squared minus F of 2. We did F of 2 before, didn't we? We said it was 40. Or we did F of 2 before and we said it was 40. So that's going to be minus then 40. All of that is over H. So that is going to be 60 plus 30H negative 5 times 2 plus H quantity squared. So that's going to be 4 plus 4H plus H squared. So that's going to be minus 20 minus 20H, bless you, minus 5h squared minus 40 all over h. Now my non-h terms should all cancel out. 60 minus 20 minus 40 cancels everything out. That leaves me then with only h terms. So I can divide them all by h. So that's going to be 30 minus 20 minus 5h. Oops. And then when I send h to 0, the h terms cancel each other out. 30 minus 20 gives me an IROC of 10 meters per second. Questions on that? Okay. Now, why we do it this way is specifically for this. We can use that method to find the IROC of this object at any time t. We can't do that using the method that we had from yesterday, the t method from yesterday. We can't. When we send t to the specific time, that only works at that specific time. But here, I can say that I want my IROC on the interval from t to t plus h. And I can set t wherever I want it to be, as long as I send h still to 0. What that allows me to do is, if given this is my function, I can say, all right, at 5 seconds it's going this fast. At 2 seconds it's going this fast. At 11 seconds it's going this fast. And I don't have to recalculate that limit every single time, because I've done it once and I did it right the first time. Okay? So, this becomes the limit as h approaches 0 of f of t plus h minus f of t all over h. So f of t plus h is going to be 30 times t plus h minus 5 times t plus h quantity squared minus f of t is going to be 30t minus 5t squared, and all of that is over h. Now we got to do some math. Oops, went a little too far. Okay, so the limit as h approaches 0 of, well, that's 30t plus 30h that's going to be minus 5 times t squared plus 2th plus h squared. So that's going to be minus 5t squared minus 10th minus 5h squared, then minus 30t plus 5t squared, and all of that is over h. Now, if I did my math right, when I simplify that numerator, all of my non-h terms should be gone. Okay? 30t minus 30t is 0. Negative 5t squared plus 5t squared is 0. And there's nothing else that simplifies. So now I can divide everything by h. That would give me 30 minus 10t minus 5h. Now I can send h to 0. By sending h to 0, any remaining h terms go away. So my IROC function at any t value is 30 minus 10t. So if I have to calculate the instantaneous velocity of my object at 2 seconds, 10 times 2 is 20, 30 minus 20 is 10. We just found that. Okay? If I wanted to calculate it at 4 seconds, 10 times 4 is 40. 30 minus 40 is negative 10. So my object is moving at negative 10 meters per second. Okay. I can just plug whatever t value I want into that, and I can get the speed that it's going at that particular time. Okay. So, in summary, okay, if I'm asking you to find a distance, how far an object is away, okay, then you're going to use the function. You're going to plug in t. Wake up, Will. If I'm asking you to find the average rate of change, 1, I'm going to give you an interval that I want you to find it on. And 2, you're going to use f of b minus f of a all over b minus a. If we're looking for the IROC, from now on, what you should be using is you should be using the limit as h goes to 0 of f of t plus h minus f of t all over h. It will make your life much, much simpler. Okay. So, what I would like you to do now is, f of t is t cubed. I want you to find the IROC function for the speed of our object at any time t. Go for it. t plus h quantity cubed is t cubed plus 3t squared h plus 3th squared plus h cubed. Okay. You can do that one of two ways. You could take the trinomial, excuse me, the three binomials, multiply them out, then double distribute again, add those all up together, and that gives you t cubed plus 3t squared h plus 3th squared plus h cubed. Okay? Or you could remember this. So this would be to the 0 power, the first power, second power, third power. So then this would be anything to the 0 power is 1. Then this would be t plus h to the first power. Second power would be t squared plus th plus h squared. Third power would be t cubed plus 3t squared h plus 3th squared plus h cubed. How did I get what? Where did I get that triangle from? Pascal's triangle. Been around for centuries. No, you've probably seen it. You should have picked it up at least in algebra 2. Yeah. Yeah. But it's a faster way of multiplying out binomials. Okay? Yeah. So we get that. Then the t cubes cancel each other out, which is what I needed it to do. And everything can be divided by h. So then this becomes 3t squared plus 3th plus h squared. Now I can send h to 0. So if h is 0, then that one goes away, and that one goes away. Anything with an h in it goes away. So my IROC function which is my speed function, is 3t squared units per second. So my position function was t cubed. My velocity, my speed function, was 3t squared. Which now if I ask what's the IROC at all of these different times, you should be able to very quickly calculate those. So the speed here then at 0 is 0. The speed at 1 is 3. At 2, what's the speed? 12. 3, what's the speed? 27. 4. What's the speed? 48. 5. What's the speed? 75. 6. What's the speed? 108. Okay. What can you tell me about my object? It's speeding up. It's accelerating, right? Okay. We know it's accelerating because the speeds are getting faster. Okay. And the change of the change. Okay. So this is plus 3, plus 9, plus 15. What's that? 21, 27, 33, right? Yeah. The rate of change of the rate of change. Ooh, what? That's. How did that get all? There we go. Now it looks better. We know that by looking at the rate of change. This is the rate of change here. These blue numbers is the rate of change of the rate of change, of the instantaneous rate of change. Okay? All right. I have a worksheet for you tonight, so you should be through sheet D by the time you come to class tomorrow. Yesterday you got sheets A and B. Today you're getting sheets D and E. And so by tomorrow you should be through sheet D, which, given the fact that I'm giving you 20 minutes to work here in class today, should be more than enough time to get done.